Disclaimer: Reggie and Royal's analysis and insights are based upon data gathered by it from various sources believed to be reliable, complete and accurate. However, no guarantee is made by Reggie and Royal, or Vision Associates LLC as to the reliability, completeness and accuracy of the information so analyzed. Reggie and Royal is in the business of gathering information, analyzing it and disseminating the analysis for informational and educational purposes only. Reggie and Royal attempts to analyze trends, not make recommendations. All statements and expressions are the opinion of Reggie and Royal and are not meant to be investment advice or solicitation or recommendation to establish market positions. Our opinions are subject to change without notice. Reggie and Royal strongly advises readers to conduct thorough research relevant to decisions and verify facts from various independent sources. Copyright 2021 Vision Associates LLC. All rights reserved.
Welcome back to the Reggie and Royal podcast. In our very first episode 2 years ago, which was entitled, Cryptocurrency, the Seventh Layer, we suggested that cryptocurrency might very well be a seventh, major technological event going back over the past 40 to 45 years, starting with centralized computing architectures. In that first podcast, we hinted that an eighth layer was in hiding, unknown at that time to most of us. We are now convinced that this eighth layer is now quite clearly in our midst, arriving with a bang in the past 6 months. Both economic and technological segments of our society are under cyclonic pressures, due to the rapid progress of artificial intelligence, AI, components. These forces will have massive impacts on our society for generations, possibly forever, and, much more so than carbon markets and cryptocurrencies. As we left episode 9, we introduced the subject of carbon neutrality and crypto. This followed episode 8, Carbon Credits and Crypto, where we looked at the rapid and strategic developments in the emerging cryptocurrency niche of mandatory carbon offsets, as they apply to the blockchain, which was the first installment in our 3-part series. Mark Cuban has been an early investor in this space, and has committed to regular purchases of carbon credits in the open market. This has been said to be one of the most significant growth opportunities over the next decade. One seasoned investor puts the segment as being, right now, where Bitcoin was a decade ago, with regard to the outstanding and lucrative growth opportunities ahead of us. Due to the relative obscurity of this topic to so much of the general public, we knew that we could not complete the discussion in less than 3 episodes. So, we have completed 2 of the 3 podcasts in this category. The third unit will now move to episode 12, where we'll describe the international carbon markets and that relationship to the cryptocurrency blockchain. And, although a lot of recent focus this year has been on the so-called Bitcoin or crypto winter, we'll place a deep dive into that topic in a future podcast. At the present time, much of the overhang of intermarket asset allocations and rebalancing, potential legislation and likely regulations on cryptocurrency is yet to be settled. As this further develops, we'll have a more significant contribution to make in a way that offers greater guidance and directions for your informed decision-making. Meanwhile, just in the past 3 months, Bitcoin and other cryptocurrencies have had their biggest up move in many months, roughly 53% in the past 6 months. This merits attention in further detail in a later discussion. And, in spite of the current cryptocurrency lull, the cryptocurrency sector is still the best performing financial asset for the past 5 years, and, for the past 10 years. Regarding the recent buzz on prominent artificial intelligence models, we created a separate briefing on these key language models, including GPT-3, GPT-3.5, the basis for ChatGPT, and GPT-4 on our webpage at reggieandroyal.com. Now, after rearranging our sequence, we now introduce what is likely to be one of the most significant topics of all time, artificial intelligence, or AI. The world of artificial intelligence, AI, is a branch of computer science that focuses on creating machines and software capable of performing tasks that typically require human intelligence. AI systems can learn from data, recognize patterns, make decisions, and adapt to changes in their environment. The ultimate goal of AI research is to develop intelligent agents that can perform a wide range of tasks, such as understanding natural language, recognizing objects and images, playing games, and solving complex problems. Natural language processing, NLP, is a subfield of AI that deals with the interaction between computers and human languages. It focuses on developing algorithms and models that enable machines to understand, interpret, generate, and respond to human language in a way that is both meaningful and contextually relevant. NLP encompasses a wide range of tasks, including text analysis, understanding and extracting information from written text, sentiment analysis, determining the sentiment or emotion expressed in a piece of text, machine translation, translating text from one language to another, named entity recognition, identifying and classifying entities, for example, names, places, dates, in text, text summarization, generating concise summaries of longer documents, question answering, providing accurate and relevant answers to user queries, conversational agents, developing chatbots and virtual assistants that can understand and respond to human language. NLP researchers use various techniques, including machine learning, deep learning, and rule-based methods, to develop models that can process and generate human language effectively. Large language models, LLMs, such as GPT-3, are a recent advancement in NLP that demonstrates impressive capabilities in various language-related tasks. Introduction. This is a brief overview of the gradual developments in AI over the past decade that have led to significant advancements in the field. Deep learning. The past decade has seen a resurgence of neural networks, specifically deep learning, which has been a primary driver of AI advancements. The development of new techniques, such as convolutional neural networks, CNNs, for image recognition and recurrent neural networks, RNNs, and transformers for natural language processing, has greatly improved AI's performance in various tasks. Large-scale datasets. The availability of large-scale datasets for training AI models has played a crucial role in improving their performance. These datasets have facilitated the training of more complex models, enabling them to learn from a wide range of examples and generalize to new situations. Computational power. Increased computational power, especially with the advent of graphics processing units, GPS, and specialized hardware like tensor processing units, DPS, has allowed researchers to train larger and deeper neural networks, which has contributed to the rapid advancements in AI transfer learning. Techniques like transfer learning, which involve pre-training models on large datasets and fine-tuning them on specific tasks, have enabled AI models to achieve state-of-the-art performance with relatively smaller amounts of task-specific data. Large language models, LLMs. Over the past few years, there has been a significant shift towards training larger and more powerful language models, such as GPT-3 by OpenAI. These models have demonstrated remarkable capabilities in various NLP tasks, including text generation, translation, summarization, and question answering. We now go further into the podcast topic, the world of artificial intelligence. What are large language models, LLMs? Large language models, LLMs, are a type of artificial intelligence model designed to generate human-like text, understand context, and provide relevant responses based on the input text. These models are typically trained on massive amounts of textual data from diverse sources, such as books, articles, and websites. LLMs use deep learning techniques, specifically neural networks, to learn patterns and structures in the text, which allows them to generate coherent and contextually appropriate responses. One of the most well-known LLMs is the GPT, Generative Pre-trained Transformer, series developed by OpenAI. The release of GPT-3, the third iteration of the model, marked a significant advancement in natural language processing, NLP, capabilities. GPT-3 has 175 billion parameters, which are the weights in the neural network that determine how well the model can understand and generate text. LLMs have a wide range of applications, including text generation. LLMs can be used to create articles, stories, or other types of content. Question answering. LLMs can be used to provide detailed answers to user queries based on the context provided. Translation. LLMs can be used to translate text between different languages accurately. Summarization. LLMs can be used to create concise summaries of longer documents. Sentiment analysis. LLMs can be used to determine the sentiment, positive, negative, or neutral, of a piece of text. Chatbots and virtual assistants. LLMs can be used to develop conversational agents that can understand and respond to user queries in a human-like manner. Large-scale datasets. The availability of large-scale datasets for training AI models has played a crucial role in improving their performance. These datasets have facilitated the training of more complex models, enabling them to learn from a wide range of examples and generalize to new situations. Computational power. Increased computational power, especially with the advent of graphics processing units, GPS, and specialized hardware like tensor processing units, DPS, has allowed researchers to train larger and deeper neural networks, which has contributed to the rapid advancements in AI transfer learning. Techniques like transfer learning, which involve pre-training models on large datasets and fine-tuning them on specific tasks, have enabled AI models to achieve state-of-the-art performance with relatively smaller amounts of task-specific data. Large language models, LLMs. Over the past few years, there has been a significant shift towards training larger and more powerful language models, such as GPT-3 by OpenAI. These models have demonstrated remarkable capabilities in various NLP tasks, including text generation, translation, summarization, and question answering. We now go further into the podcast topic, the world of artificial intelligence. What are large language models, LLMs? Large language models, LLMs, are a type of artificial intelligence model designed to generate human-like text, understand context, and provide relevant responses based on the input text. These models are typically trained on massive amounts of textual data from diverse sources, such as books, articles, and websites. LLMs use deep learning techniques, specifically neural networks, to learn patterns and structures in the text, which allows them to generate coherent and contextually appropriate responses. One of the most well-known LLMs is the GPT, Generative Pre-trained Transformer, series developed by OpenAI. The release of GPT-3, the third iteration of the model, marked a significant advancement in natural language processing, NLP, capabilities. GPT-3 has 175 billion parameters, which are the weights in the neural network that determine how well the model can understand and generate text. LLMs have a wide range of applications, including text generation. LLMs can be used to create articles, stories, or other types of content. Question answering. LLMs can be used to provide detailed answers to user queries based on the context provided. Translation. LLMs can be used to translate text between different languages accurately. Summarization. LLMs can be used to create concise summaries of longer documents. Sentiment analysis. LLMs can be used to determine the sentiment, positive, negative, or neutral, of a piece of text. Chatbots and virtual assistants. LLMs can be used to develop conversational agents that can understand and respond to user queries in a human-like manner. It's important to note that while LLMs can generate impressive results, they also have limitations, such as generating plausible-sounding but incorrect or nonsensical answers, sensitivity to the phrasing of input, and potential biases present in their training data. Researchers and developers continue to work on improving LLMs, addressing their limitations, and finding new applications for these powerful models. Now, let's discuss the importance and usefulness of LLMs in natural language processing and artificial intelligence. Large language models, LLMs, have become increasingly important and useful in natural language processing, NLP, and artificial intelligence, AI, due to their ability to understand, generate, and manipulate human language effectively. This has led to significant advancements in various language-related tasks and applications. Here are some key reasons why LLMs are important and useful in NLP and AI. Pre-trained knowledge. LLMs are pre-trained on massive amounts of text data, which enables them to acquire a broad understanding of language, context, and domain-specific knowledge. This pre-training allows LLMs to be fine-tuned for specific tasks using relatively smaller amounts of task-specific data, which can lead to improved performance and faster development of NLP applications. Transfer learning. The ability of LLMs to leverage transfer learning across different tasks and domains has made them highly adaptable and versatile. As a result, developers can use a single LLM as the foundation for multiple NLP applications, reducing the need to train separate models for each task. Improved performance. LLMs have demonstrated state-of-the-art performance across a wide range of NLP tasks, such as text generation, translation, summarization, question answering, and sentiment analysis. This improved performance has led to the development of more accurate and reliable AI systems that can better understand and interact with human language. Multitask learning. LLMs can be trained to perform multiple tasks simultaneously, which can lead to better generalization and more efficient use of resources. This multitask capability enables the development of AI systems that can perform a variety of language-related tasks without the need for multiple specialized models. Human-like interactions. LLM's ability to generate coherent and contextually appropriate text has facilitated the development of more advanced conversational agents and chatbots. These systems can better understand user queries and provide more natural, human-like interactions, improving the overall user experience. Creative applications. LLMs can be used in various creative applications, such as generating poetry, stories, or other forms of content. This has opened up new possibilities for exploring the intersection of AI and artistic expression. Despite their importance and usefulness, LLMs also have limitations, such as generating plausible-sounding but incorrect or nonsensical answers, sensitivity to the phrasing of input, and potential biases present in their training data. Addressing these limitations and ensuring the safe and responsible use of LLMs remains an ongoing challenge for researchers and developers in the field of AI and NLP. We'll now highlight the potential benefits and challenges of using LLMs in different industries. Large language models, LLMs, can offer numerous benefits to various industries, but they also come with certain challenges. Here, we'll highlight some of the potential benefits and challenges of using LLMs across different industries. Benefits: healthcare. LLMs can support medical professionals by providing accurate and up-to-date information, assisting in diagnosing diseases, analyzing electronic health records, and generating personalized health recommendations. These models can also enable the creation of advanced chatbots for patient support and medical consultations. Finance. LLMs can be employed to analyze financial documents, news articles, and social media to identify trends and inform investment decisions. They can also help automate tasks like customer support, fraud detection, and financial reporting. Legal. LLMs can assist in legal document analysis, contract generation, and the identification of relevant case law or regulations. They can also support the automation of routine tasks, such as legal research and document drafting, which can save time and reduce costs. Education. LLMs can be used to develop personalized learning materials, provide tutoring or support in various subjects, and create adaptive learning systems that cater to individual students' needs. They can also help teachers by automating tasks such as grading and providing feedback. Customer service. LLMs can power advanced chatbots and virtual assistants that can handle customer queries, provide personalized recommendations, and resolve issues more efficiently than traditional customer service methods. Marketing and content creation. LLMs can aid in creating high-quality, engaging content for marketing campaigns, social media, and blogs, as well as generating personalized email campaigns and product recommendations. Challenges: data quality and biases. LLMs may inadvertently perpetuate biases present in their training data, leading to biased outputs and potentially harmful consequences. Ensuring high-quality, unbiased data for training LLMs is essential. Ethical considerations. The use of LLMs raises ethical concerns, such as privacy, surveillance, and the potential for misuse in generating misleading or harmful content. Establishing guidelines and best practices for the ethical use of LLMs is crucial. Explainability and interpretability. LLMs are often considered black boxes, making it difficult to understand how they arrive at their outputs. This lack of explainability can pose challenges in industries that require transparency and accountability, such as healthcare and finance. Computational resources. Training and deploying LLMs can require significant computational resources, which can be expensive and may pose a barrier to entry for smaller organizations. Error handling. LLMs can sometimes generate incorrect or nonsensical outputs, which can lead to confusion or misinformation. Developing mechanisms to handle and correct such errors is important to ensure the reliability and trustworthiness of LLM-powered systems. Regulation and compliance. As LLMs become more integrated into various industries, ensuring compliance with industry-specific regulations and data protection laws will be essential. This may involve the development of industry-specific LLMs that adhere to relevant guidelines and best practices. While LLMs can offer significant benefits to various industries, addressing these challenges will be crucial to ensure their responsible and effective use. 3. History of large language models. Now, we'll discuss the history of LLMs and their evolution from earlier language models. The history of large language models, LLMs, and their evolution can be traced back to the early days of artificial intelligence and natural language processing. Here's a brief overview of the development of LLMs and their predecessors. Early AI and NLP. In the 1950s and 1960s, AI pioneers began exploring rule-based methods for natural language processing, such as constructing formal grammars and using symbolic manipulation. These early efforts laid the foundation for subsequent developments in NLP and AI statistical models. In the late 1980s and 1990s, statistical methods, such as n-gram models and hidden Markov models, became popular for NLP tasks. These models captured the probability of words or characters occurring in sequences, but they were limited in their ability to model long-range dependencies and complex linguistic structure. Neural networks. In the late 1990s and early 2000s, neural networks were introduced to NLP. Researchers started using feed-forward and recurrent neural networks, RNNs, for various tasks, such as language modeling and machine translation. However, The potential of neural networks was yet to be fully realized due to computational limitations and smaller training datasets. Word embeddings and deep learning. In the 2010s, word embeddings, such as Word2Vec and GloVe, emerged as a powerful technique for representing words as continuous vectors, capturing semantic and syntactic relationships. The success of word embeddings coincided with the resurgence of deep learning, which allowed for the development of more complex neural network architectures, such as convolutional neural networks, CNNs, and long short-term memory networks, LSTMs. Attention mechanisms and transformers. In 2017, the transformer architecture was introduced by Vaswani et al. In the paper Attention is All You Need. This architecture leveraged self-attention mechanisms to better capture long-range dependencies and overcome some limitations of RNNs and LSTMs. Transformers quickly became the backbone of many state-of-the-art NLP models. Pre-training and fine-tuning. With the introduction of models like Elmo, OMFIT, and BERT, the concept of pre-training and fine-tuning gained popularity. These models were pre-trained on large-scale text datasets to learn general language representations and then fine-tuned on specific tasks, resulting in significant improvements in performance across a wide range of NLP tasks. Large language models, LLMs. Building on these developments, LLMs such as GPT-2 and GPT-3 by OpenAI emerged, demonstrating impressive capabilities in generating coherent and contextually appropriate text. These models utilized the transformer architecture and were trained on massive datasets, which allowed them to achieve state-of-the-art performance on various NLP tasks. Throughout their history, LLMs and their predecessors have evolved significantly, driven by advancements in neural network architectures, computational power, and the availability of large-scale datasets. As research continues, it is likely that we will witness further improvements and innovations in the field of natural language processing and artificial intelligence. Let's introduce some of the key players and their contributions to the development of LLMs. Several key players have contributed significantly to the development of large language models, LLMs. These include researchers, organizations, and research groups that have made groundbreaking advancements in the field of natural language processing, NLP, and deep learning. Here are some of the key contributors and their notable achievements. Yoshua Bengio, Geoffrey Hinton, and Yann LeCun, often referred to as the godfathers of deep learning. These three researchers have made foundational contributions to neural networks and deep learning, which underpin the development of LLMs. Their work on backpropagation, convolutional neural networks, CNNs, and unsupervised learning laid the groundwork for many advances in NLP and AI. Thomas Mikolov, as part of the Google Brain team, Mikolov developed the Word2Vec algorithm, which revolutionized the way words are represented in NLP tasks. Word2Vec embeddings played a crucial role in the adoption of deep learning techniques for NLP and influenced the development of contextualized word representations. Alec Radford, Ilya Sutskever, and the OpenAI team, OpenAI, co-founded by Ilya Sutskever, has been instrumental in the development of LLMs. Alec Radford, in particular, has made significant contributions with the development of the GPT, Generative Pre-trained Transformer, series of models, including GPT-2 and GPT-3. These models have set new standards for state-of-the-art performance in numerous NLP tasks. Jacob Devlin and the Google AI language team. Jacob Devlin and the Google AI language team developed BERT, bidirectional encoder representations from transformers, a highly influential model that introduced the concept of bidirectional context in pre-training and fine-tuning. BERT has had a significant impact on NLP research and applications and spawned several variants and adaptations. Ashish Vaswani and the Google Brain team. Ashish Vaswani and his colleagues at Google Brain introduced the transformer architecture, which has become the backbone of many LLMs. Their paper Attention is All You Need revolutionized NLP by demonstrating the effectiveness of self-attention mechanisms in capturing long-range dependencies and addressing some limitations of RNNs and LSTM. Jeremy Howard, Sebastian Reuter, and the Fast.ai team. Jeremy Howard and Sebastian Reuter, along with the Fast.ai team, contributed to the development of OMFIT, Universal Language Model Fine-Tuning, which introduced the concept of transfer learning in NLP. Their work has influenced the adoption of pre-training and fine-tuning techniques in LLMs and other NLP models. Matthew Peters and the Allen Institute for AI team. Matthew Peters and the team at the Allen Institute for AI developed Elmo, embeddings from language models, a contextualized word representation model that captured both syntactic and semantic information. Elmo was a precursor to the development of transformer-based LLMs and their success in various NLP tasks. These key players and their contributions have greatly shaped the development of LLMs, pushing the boundaries of what is possible in natural language processing and artificial intelligence. Their work continues to inspire ongoing research and innovation in the field. We'll now highlight the latest breakthroughs in LLMs, such as GPT-3 and its potential implications. GPT-3, Generative Pre-trained Transformer 3, is one of the latest breakthroughs in the field of large language models, LLMs. Developed by OpenAI, GPT-3 has garnered significant attention due to its impressive capabilities and potential implications for various applications. Some of the key aspects and implications of GPT-3 include: scale. GPT-3 is one of the largest LLMs, with 175 billion parameters. This scale allows GPT-3 to capture an enormous amount of information and develop a deep understanding of language structure, context, and semantics, which contributes to its impressive performance on numerous NLP tasks. Few-shot learning. GPT-3 demonstrates an ability to perform few-shot learning, which means it can effectively learn a new task with just a few examples. This capability sets GPT-3 apart from many other LLMs and makes it more versatile and adaptable for a wide range of applications. Task-agnostic. GPT-3 is a task-agnostic model, meaning it can perform well on various NLP tasks without any task-specific fine-tuning. This versatility makes GPT-3 applicable to a wide range of use cases, from text summarization and translation to question answering and conversational AI. Potential applications. GPT-3's capabilities have opened up new possibilities for applications in diverse domains, such as healthcare, finance, legal, education, and customer service. For instance, GPT-3 can be used to develop advanced chatbots, generate personalized content, assist with legal research, or provide educational support. Ethical implications. The power and versatility of GPT-3 also raise ethical concerns, such as the potential to generate misleading or harmful content, perpetuate biases, or create privacy and surveillance issues. Addressing these concerns and ensuring the responsible and ethical use of GPT-3 and other LLMs is a priority for researchers, developers, and policymakers. Computational cost. GPT-3's size and complexity come with a substantial computational cost for both training and inference. This cost presents challenges for organizations with limited resources and has implications for the environmental impact of training and deploying LLMs at such scale. The breakthroughs and potential implications of GPT-3 have generated significant excitement and discussion in the AI and NLP communities. As research continues and more powerful LLMs are developed, it will be essential to address the challenges and ethical considerations that accompany these advancements to ensure that the benefits of LLMs are realized responsibly and equitably. For potential benefits and challenges of large language models. We'll now discuss the potential benefits of LLMs, such as increased efficiency, more accurate natural language processing, and improved language translation. Large language models, LLMs, like GPT-4 have numerous potential benefits, particularly in the fields of natural language processing, language translation, and efficiency in various applications. Here, we will discuss some of the key advantages of LLMs. Increased efficiency. LLMs can automate several tasks that previously required human intervention, such as answering questions, summarizing text, and generating content. As a result, businesses and individuals can save time and resources, leading to more efficient workflows and increased productivity. More accurate natural language processing. LLMs have shown significant improvement in understanding and processing natural language compared to their predecessors. This increased accuracy allows for better understanding of user intent, more relevant search results, and improved sentiment analysis, among other applications. Improved language translation. The advancements in LLMs have led to more accurate and nuanced translations between languages. This has made it easier for people to communicate across language barriers and access information in languages they might not be familiar with. Moreover, it has also facilitated better cross-cultural understanding and cooperation. Enhanced creativity. LLMs can generate human-like text, which can be used to inspire and assist with creative tasks such as writing, poetry, and advertising. AI-generated content can offer new perspectives and ideas, enabling users to explore novel concepts and approaches. Personalized learning and tutoring. LLMs can be employed as virtual tutors, providing personalized learning experiences tailored to individual needs. They can adapt their teaching style and content to suit each learner, offering explanations, examples, and feedback in real time. Accessibility. LLMs can be used to develop tools that improve accessibility for people with disabilities, such as generating image captions for the visually impaired or converting text-to-speech for those with reading difficulties. Improved customer service. LLMs can be deployed as virtual assistants, helping businesses provide faster and more accurate customer support through chatbots and email. This can lead to increased customer satisfaction and reduced wait times. Data analysis and insights. LLMs can be used to analyze vast amounts of textual data, extracting valuable insights and trends. This can help businesses and researchers make more informed decisions and discover new opportunities. Despite these numerous benefits, it is crucial to recognize and address the ethical concerns and potential negative consequences associated with LLMs, such as biased behavior, the spread of misinformation, and job displacement. By developing LLMs responsibly and deploying them thoughtfully, we can harness their potential while mitigating risks. Discuss the challenges associated with LLMs, such as bias, ethics, and privacy concerns. Large language models, LLMs, have demonstrated remarkable capabilities and potential benefits, but they also come with several challenges and concerns. Some of the most notable challenges associated with LLMs include bias, ethics, and privacy issues. Let's discuss these challenges in more detail. Bias. LLMs are trained on vast amounts of data from the internet, which includes biased, outdated, or otherwise problematic content. As a result, these models can inadvertently learn and perpetuate these biases, leading to biased outputs and decision-making. This can have significant ramifications, particularly in sensitive areas such as hiring, lending, and law enforcement. Ethics. The use of LLMs raises several ethical questions, such as the extent to which they should be allowed to generate content or make decisions autonomously. There are concerns about the potential for LLMs to create fake news, deepfakes, and other malicious content, which can have serious consequences for individuals and society. Additionally, there are questions about who should be held accountable for the outputs and actions of AI systems, and how to ensure that they align with human values. Privacy. LLMs are trained on large datasets that may contain personal or sensitive information. This raises concerns about the potential for LLMs to inadvertently expose private data or generate outputs that reveal sensitive information about individuals or organizations. Ensuring privacy preservation while still maintaining the utility of LLMs is a significant challenge. Energy consumption and environmental impact. Training large-scale LLMs requires considerable computational resources and energy, which contributes to carbon emissions and raises concerns about their environmental impact. Developing more energy-efficient models and training techniques is crucial to mitigate this challenge. Interpretability and explainability. LLMs are often considered black boxes due to their complex architectures and the difficulty in understanding how they arrive at specific outputs. This lack of interpretability can make it challenging to identify the root causes of biased or erroneous outputs and to develop effective solutions to address these issues. Control and safety. Ensuring that LLMs generate safe and useful content can be challenging, particularly when their outputs are unpredictable or when they are used in unintended ways. Developing mechanisms to control AI behavior, prevent harmful outputs, and ensure that LLMs are used responsibly is essential. Job displacement. While LLMs can automate various tasks and improve efficiency, they also have the potential to displace jobs, particularly in roles that involve repetitive or routine tasks. Ensuring a just transition for affected workers and adapting educational and training systems to prepare for the future of work is crucial. To address these challenges and concerns, researchers, policymakers, and industry stakeholders need to collaborate on the development of guidelines, best practices, and regulatory frameworks that promote the responsible development and deployment of LLMs. By doing so, we can harness the potential benefits of LLMs while mitigating their risks and negative consequences. We should now highlight the potential impact of LLMs on society as well as the need for regulation and ethical considerations. Large language models, LLMs, have the potential to profoundly impact society in various ways, both positive and negative. As these models continue to advance, it is essential to consider the need for regulation and ethical considerations to ensure that their deployment aligns with the broader social good. Potential impact on society. Automation and efficiency. LLMs can automate numerous tasks involving natural language processing, leading to increased efficiency and productivity in various domains, such as customer service, content creation, and data analysis. Improved communication and translation. LLMs can facilitate better communication and understanding across language barriers, enabling greater access to information and fostering global collaboration. Accessibility. The development of LLM-based tools can improve accessibility for people with disabilities, helping them engage more fully with digital content and communication. Education. LLMs can contribute to personalized learning experiences, acting as virtual tutors and assisting students in mastering various subjects according to their individual needs. Creativity and innovation. LLMs can enhance creativity by generating human-like text and assisting in creative tasks, inspiring new ideas and approaches. However, the impact of LLMs is not universally positive, and there are potential risks and unintended consequences that must be addressed. Bias. LLMs can perpetuate and exacerbate existing biases, leading to unfair and potentially harmful outcomes. Ethical concerns. The use of LLMs raises ethical questions regarding their autonomy, accountability, and potential for malicious use, such as generating fake news, deepfakes, or other harmful content. Privacy. LLMs may inadvertently expose private or sensitive information, raising privacy concerns for individuals and organizations. Job displacement. The automation enabled by LLMs could lead to job displacement in certain sectors, necessitating adaptation and job retraining efforts. Need for regulation and ethical considerations to ensure that the deployment of LLMs is responsible and aligns with societal values. The following actions should be considered. Transparency. Encourage transparency in LLM development, including the disclosure of training data sources, methodologies, and potential biases. Bias mitigation. Develop techniques to identify and reduce biases in LLMs, promoting fairness and inclusivity in AI-generated outputs. Privacy preservation. Implement privacy-preserving techniques to protect sensitive information and ensure that LLMs do not inadvertently divulge private data. Accountability. Establish clear guidelines and regulations regarding the accountability of LLM developers, operators, and users, ensuring that AI systems are used responsibly and ethically. AI ethics guidelines. Develop and promote ethical guidelines and best practices for LLM development and deployment, addressing issues such as autonomy, malicious use, and human values alignment. Public and stakeholder involvement. Engage the public and diverse stakeholders in discussions about the development, deployment, and regulation of LLMs, ensuring that a broad range of perspectives are considered. Education and workforce adaptation. Invest in education and training programs to prepare the workforce for the future of work, fostering skills that complement LLMs and other AI technologies. By addressing these concerns and implementing regulatory and ethical frameworks, we can harness the potential benefits of LLMs while minimizing risks and negative consequences. This will enable society to reap the rewards of artificial intelligence in a responsible and equitable manner. Case studies. Let's discuss some real-world examples of the use of LLMs in different industries, such as healthcare, education and finance. Large language models, LLMs, have been applied in various industries, demonstrating their potential to revolutionize processes and provide value across diverse domains. Here are some real-world examples of LLM use in healthcare, education, and finance. Healthcare and medical information retrieval. LLMs can be employed to search and retrieve relevant medical information from vast repositories of research articles, helping healthcare professionals stay up to date with the latest findings and improve patient care. Medical chatbots. LLMs can power chatbots that provide general health information, appointment scheduling, and symptom checking, reducing the load on healthcare professionals and providing patients with quick and accurate information. Clinical documentation. LLMs can assist healthcare providers in generating clinical documentation, such as progress notes and discharge summaries, saving time and reducing the burden of administrative tasks. Drug discovery. LLMs can analyze vast amounts of biomedical literature and data to identify potential drug candidates, predict drug interactions, and optimize therapeutic strategies. Education. Personalized tutoring. LLMs can serve as virtual tutors, providing personalized learning experiences tailored to individual students' needs, offering explanations, examples, and feedback in real time. Content generation. LLMs can generate educational content such as quizzes, practice questions, and summaries of complex topics, making it easier for educators to curate and create engaging learning materials. Language learning. LLMs can be employed in language learning applications, providing personalized exercises, grammar explanations, and conversation practice for learners of different languages. Mitigating biases in LLM-generated outputs, which could lead to biased decision-making and unfair treatment of certain individuals or entities. In conclusion, while LLMs have demonstrated promising successes across various industries, it is crucial to address the associated challenges to ensure their responsible and effective deployment. By addressing issues such as accuracy, privacy, and bias, we can harness the full potential of LLMs while minimizing potential risks. Here's an analysis of the potential future impact of LLMs on society as a whole. The potential future impact of large language models, LLMs, on society as a whole is vast and far-reaching. As these models advance and become more integrated into various aspects of daily life, we can expect both positive and negative consequences. Here, we analyze some key areas of potential impact. Automation and productivity. LLMs have the potential to significantly increase automation and productivity across numerous industries. By taking over tasks involving natural language processing, LLMs can save time, increase efficiency, and allow workers to focus on more strategic and creative tasks. However, this increased automation could also lead to job displacement, necessitating adaptation and job retraining efforts. Democratization of knowledge. LLMs can help democratize access to knowledge by providing information and resources in multiple languages and formats. This improved access to information can empower individuals and communities, fostering innovation and collaboration on a global scale. However, addressing biases and ensuring fair representation in LLM-generated content will be critical to avoid perpetuating existing inequalities. Digital divide. The widespread adoption of LLMs may exacerbate the digital divide, as those without access to advanced technologies may fall further behind in terms of access to information, resources, and opportunities. Efforts to bridge the digital divide and ensure equitable access to LLMs and their benefits will be essential. Ethics and regulation. The increasing influence of LLMs on society will necessitate robust ethical guidelines and regulatory frameworks to address issues such as autonomy, accountability, and the prevention of malicious uses. Balancing innovation and responsible development will be crucial to fostering a future where LLMs serve the greater good. Privacy and security. As LLMs become more integrated into everyday life, privacy and security concerns will become increasingly important. Ensuring that LLMs handle sensitive data responsibly and do not inadvertently expose private information will be essential to maintaining trust in these technologies. Social interaction. The widespread use of LLMs may transform the way we communicate and interact with one another, both online and offline. LLM-powered virtual assistants, chatbots, and content generators may change the nature of conversations, alter the way information is consumed, and potentially affect interpersonal relationships. Creativity and intellectual property. LLMs have the potential to revolutionize creative processes by generating human-like text and assisting in various creative tasks. This raises questions about the future of creativity, originality, and intellectual property rights, as the distinction between human-generated and AI-generated content becomes increasingly blurred. In summary, the potential future impact of LLMs on society is immense, offering both opportunities and challenges. By proactively addressing the associated risks, ethical considerations, and regulatory concerns, we can work towards a future where LLMs contribute positively to societal progress and well-being. Conclusion. The use of large language models, LLMs, in artificial intelligence and natural language processing offers numerous potential benefits and presents several challenges. Here, we reiterate the main points: potential benefits, automation and efficiency. LLMs can automate a wide range of tasks involving natural language processing, leading to increased efficiency and productivity across various industries. Improved communication and translation. LLMs have the potential to enhance communication and understanding across language barriers, facilitating global collaboration and access to information. Accessibility. LLM-based tools can improve accessibility for people with disabilities, enabling them to engage more effectively with digital content and communication. Education. LLMs can contribute to personalized learning experiences, serving as virtual tutors and assisting students in mastering various subjects according to their individual needs. Creativity and innovation. LLMs can augment human creativity by generating human-like text and assisting in creative tasks, inspiring new ideas and approaches. Challenges. Bias. LLMs can perpetuate and exacerbate existing biases in their outputs, leading to unfair and potentially harmful outcomes. Addressing these biases requires ongoing research and the development of bias mitigation techniques. Ethical concerns. The use of LLMs raises ethical questions regarding their autonomy, accountability, and potential for malicious use, such as generating fake news or deepfakes. Establishing ethical guidelines and regulatory frameworks will be crucial to address these concerns. Privacy. LLMs may inadvertently expose private or sensitive information, raising privacy concerns for individuals and organizations. Ensuring that LLMs handle and process data responsibly and securely is essential. Job displacement. The automation enabled by LLMs could lead to job displacement in certain sectors, necessitating workforce adaptation and job retraining efforts. In conclusion, while LLMs offer numerous potential benefits in artificial intelligence and natural language processing, they also present significant challenges that must be addressed. By proactively confronting these challenges and promoting responsible development and deployment, we can harness the power of LLMs to benefit society while minimizing potential risks and negative consequences. Our next podcast, episode 11, is entitled, The World of Artificial Intelligence, How is it expected to impact our society? We will further define artificial intelligence, with a discussion of the impacts of AI, the job markets, the healthcare industry, and upon our society in general. We are assured of major impacts on career paths, specific industry growth and disruptions, as well as economic and personal impacts, so be sure to catch us next time, for Reggie and Royal Perspectives podcast on the economy, cryptocurrency, history, and business. If you enjoyed the podcast, don't forget to smash the like button, and subscribe to our channel. Until next time, let's stay busy.